All right, well, let's go ahead and get started. Thank you for attending today's training, Battery Chemistry 101. This is a NABCEP accredited training. So if you're here for CE credits, we're going to need you to stay for the entire session. It's about an hour long. At the end of the slides, we'll show you an email address where you can send us an email to get your NABCEP credits. We'll want to make sure that you confirm how your name should read on the NABCEP credits, so that we don't issue the credit incorrectly and give you any problems getting the credits. We do have a Q&A. I see that it is being used by a couple attendees already. Thank you very much. And we will talk about temperatures in this webinar. First thing we're going to do is talk a little bit about our company history and overview. Starting back in 2010, as OES Energy, we were providing energy solutions for the film and broadcast industry. Moving through 2011 and 12, there was some interest from the Department of Defense in replacing some diesel generators and lead acid batteries. Lithium-ion products didn't have a great name at that point because of some hazards that had been identified. So through our lithium iron phosphate chemistry, we're able to demonstrate that our batteries were reliable and safe. The Department of Defense did some testing and ultimately used our batteries in forward operating basis. Moving forward in 2013-14, we started to expand that product line, having some standalone units, some units on wheels. 2015-16, we relaunched a Simplify Power. You can see an access cabinet there. We also started to implement some other products, including in 2017 and on, high voltage and our Amplify battery. And most excitedly, recently we were acquired by Briggs & Stratton, enabling us to leverage their manufacturing history to release a vertically integrated ESS system. We'll go over this in great detail later on in the presentation, but it's a very exciting proposition that we are unable to offer now. So here at Simplify, we're talking about three main points: safe, proven, and simple. Well, what do we mean by safe? I mentioned earlier that some lithium-ion batteries had gotten a bad rap. They had propensity to have fires or thermal runaway. Well, this was a result of a chemistry issue. So by using a cobalt-free chemistry, our product does not have a risk of thermal runaway with fire propagation. We are UL certified 1642, 1973, 9540 through some 9540A testing, and we'll go over that on the next slide. And we also have UN DOT certification on some of our batteries, which means you can put them on a domestic air flight. Very important if that's what you need. We also have certifications from a California rebate program called SGIP. So if you're using our batteries to participate in that rebate program, we are approved. We are proven. In that last slide I showed you, we have been around since 2010. That's over a dozen years now where we've been in the field, and we have batteries that are still out there. You know, with a warranted life of 10 years, the fact that we have batteries still in the field working is a claim not many manufacturers can make. We're deployed in more than 45 countries with something like 250 megawatt hours installed worldwide. Like I mentioned, US Army and Marine Corps have used our product. And we try and be a business that demonstrates that we can have social impact and profitability. An example of this is our IDEA program, where 1% of our annual revenue is given back through projects in a kind of a grant formation, where if a project can prove that they are a worthy impact, we'll happily provide some batteries. We've done this for schools, health clinics, some park services. And we're manufactured in the US. So there's nothing really to hide behind there. We're here. And it's a simple product. You know, it integrates with a lot of different existing optimized energy solutions like inverters and charge controllers. You can use your power for backup, for resiliency. And there's also a lot of great ways to save money. What does that look like? We'll go over that in a second. We talked a little bit about UL listings. UL stands for Underwriter Laboratories. So they're a third party. And what they're doing is they're taking our product and testing it for safety. Most of that safety is around fire. You know, like I said earlier, there was a bad rap about these batteries early on, lithium-ion batteries in particular, with fire safety issues. So By going through UL certifications, 1642, we're going to look at the cell level. These kind of look like a little AA battery, maybe a little bit bigger, but same form factor, wrapped in metal. 1973 is going to be the battery itself inside the case. And 9540 is going to be the system level. Now, there's a lot of talk about 9540A. Now, that's not a certification. It is a test protocol. And 9540A is going to inform how your 9540 certification looks. So, for example, if the 9540 test determines that you need a certain piece of equipment to be safe from fire, your 9540 certification is going to require that equipment be used. So why you ask, why do I need UL certifications? Well, if you're ever going to try and get signed off by an AHJ or authority having jurisdiction, you may need UL certified equipment to pass inspection. There's a lot of different AHJs out there, city, state, federal, and they're all going to interpret these codes differently. So having a bevy of approvals ahead of time is going to allow you to go into that project knowing that you're going to get signed off. And in general, it's always a good idea to have a UL certification because it's safety. If you're bringing these products into your home or your business, it's a good thing to have a third party have looked at it and determined that it's not going to spontaneously burst into flames, right? We're always going to recommend you check with your AHJ about what codes you need to be following, what UL certifications you need, but we're confident we have them, our product's safe, and we should be able to get you across the finish line. Another reason you might want a UL certification is insurance purposes. If the insurance company is looking at your project and they see that you're not using safe equipment, they may not underwrite your project. And then, despite all of these, you might say, hey, Chuck, I'm off grid. Nobody's looking. I don't need UL certifications. Well, what if you sell? If you sell the property, they may look at that equipment and say, this is not UL certified, and could be a hang up on the sale. So why do we need energy storage, or why do we need distributed energy resources? Well, we all know that the escalating energy costs are a real thing. We feel it in our local utilities, increasing rates, sometimes very regularly. We feel it at the gas pump. The price of oil is going up, and a lot of electric generation on the grid is driven from those prices of oil. We also have a failing infrastructure. In the last couple of years, we've seen some, examples where in California, due to high winds and dry conditions, utilities will turn off the power just to be safe. It's because we have these overhead power lines that are aging out. Or like in Texas recently, where there was a weather event, a lot of cold weather, a lot of people using a lot of energy, and the grid just couldn't support it. So you had widespread outages. Putting energy in people's hands allows them to be resilient through those events. And then there's another issue about decarbonization. We are potentially facing the largest challenge mankind has ever faced in global warming. And a lot of us in the industry feel very passionate that we are part of the solution by giving people energy that they can control, clean energy that they can recharge their batteries with. We can be leading the charge on saving our planet. We can also be saving money, which is a really important proposition for a lot of customers. So a couple different ways to do this. On the left, we have this graph labeled peak shaving, where you'll see a couple peaks in purple. This is a demand profile. So you could think about it as when you come home on a hot day from work, you turn on the air conditioning, you start the oven for dinner, and all of a sudden you have those two loads stacked on top of each other. That's the demand and energy or power that you're using. A lot of utilities will look at that instantaneous or 15-minute demand and drive your monthly utility bill based on that value. So if you have energy storage, you can program that system to say, hey, I don't want to have that peak value driving my bill. I want to keep that value low, keep my bill low. And you could program your inverter to say, I don't want to see more than 5 kW pulled from the grid. And if we start to see that demand approaching 5 kW, we can tell our inverter to step up and provide battery power to offset that demand. Another rate signal that we're seeing utilities use is called time of use. Well, the utilities have identified that the most expensive part of the day for them to make power for the grid is generally in the afternoon. Again, it's people coming home, turning on the air conditioning, starting the oven for dinner. So what the utilities are doing is they're charging you a peak rate during the afternoon. The most expensive energy of the day is during the afternoon. Well, if you have energy storage, you can avoid those peak rates by discharging your battery to your loads. You run that AC and run that oven with your batteries running, and you're not buying as much electricity from the grid during that most expensive time. Now, where this really works well is when you have solar and storage. And this is going to be a paradigm shift that I think we're going to see more and more as utilities in general are either devaluing the export rate of solar. We're seeing that in California. The NEM 3 decision is happening this week, and it looks like export rates are going to be cut drastically. There's states that don't have export rates. So if you're making solar in the middle of the afternoon and you're not home, the utility says, thank you very much for that, here's $0. When you have energy storage, you can avoid that. You can use your solar during the day, charge your batteries, and then when you get home later, use that same energy that you've stored to run your loads. So you're doing two things. You're avoiding a devalued or non-existent export rate, and you're avoiding buying at a higher import rate during the time of use. Name of the presentation is Battery Chemistry 101, so let's dive into that. This chart's going to list a number of different battery chemistries. Now, these are all considered lithium-ion, so it's a catch-all phrase, but they're all very different. In green, we've got our chemistry, that's lithium iron phosphate. The four in purple all contain cobalt. And as we can see from this chart, they all have very similar attributes. So we talked a little bit about the danger of thermal runaway and fire. You can see our product does not have that danger, whereas the four with cobalt do. We'll go over thermal runaway in the next couple slides. Another aspect about including cobalt is that it is a toxic element. So our battery does not contain that, and it is not toxic. Now, no battery is truly landfill safe. Batteries need to be recycled in the proper method. Good news is that your local waste management or similar organizations probably already got a battery recycling program established. So contact them and see where you can take your lithium-ion batteries for recycling. Don't put them in the landfill. Another aspect about the elements that we choose to put in our batteries is the way that we extract them. So lithium iron phosphate is using iron. That's a very common element on the planet. Cobalt, not so much. It exists in high quantities in relatively few places. And unfortunately, in some of those places, the extraction process is questionable, maybe even considered abusive in the form of labor that is used to extract that. We want to avoid those conflict minerals. Coming back to those chemistry issues about temperature and stuff, when we talk about ventilation, our battery does not require it, where a cobalt battery may very well require ventilation, may also require cooling equipment, like a radiator pumping coolant through, may also require safety monitoring equipment, like heat sensors. All of those are additional costs that you're passing on to your customers because of that choice in chemistry of the battery. We also have the ability to withstand a larger temperature range because of our chemistry, and we'll have a slide on that coming up too. So we covered a little bit about chemistry. Another important consideration is form factor. So we use the lithium iron phosphate chemistry, like I said, and a cylindrical form factor. I called it a AA battery, but it's not exactly a AA, but it looks like that. You have a metal casing, the anode and cathode are spooled together inside, and you have positive and negative terminals on opposite sides of the battery cell. Other lithium ion cell form factors include pouch cells. So a pouch cell, you can see here in the middle, has two terminals right next to each other. That increases the opportunity for a short circuit. If something were to cross those two terminals, that pouch could short out. They're also flexible. That's not necessarily a good thing. The flexibility allows that battery to expand and contract, and that can degrade the battery over time. We'll have some examples of that coming up shortly. A third type of form factor is prismatic. Now, this is a more rigid than pouch form factor, but it still allows for some expansion and contraction. And to my earlier point about the terminals, they are right next to each other, potentially leading to an opportunity for increased shorts. So what do we mean thermal runaway? Well, thermal runaway is when a battery becomes hot enough that a chemical reaction begins generating more heat. And that's really the trick, is that it starts to run away. The heat increases, and that causes more increase and generally spreads. That's where we talk about thermal runaway with propagation to another cell, or in the case of the photo on the right, to the casing of the product itself. It's a phone that was unfortunately prone to some thermal runaway events, resulting in it being banned from flights. So what causes thermal runaway? Well, generally it's that issue I was talking about of a short circuit. Could also be from damage. You know, we've heard news stories about cars, electric vehicles that are in a crash, and the battery catches fire, and the fire department can't put it out because the batteries themselves are experiencing this thermal runaway. They're spreading from battery, and the fire department literally has to wait for the fire to burn itself out. But there are other ways. An external heat source can cause thermal runaway. Like I said, shorts, puncturing, even overcharging. All of these can cause thermal runaway. So there's a number of ways to get there. And what happens when we get there? Well, a big thing to understand about thermal runaway is that they're not all the same. Depending on the chemistry, you might have different outcomes. So generally what occurs is the elements within the battery during thermal runaway will start to vaporize. And if they are contained, they don't ignite. But if they escape, they're toxic and flammable. Not a good combination. So when we look at our lithium iron phosphate chemistry, we can identify that thermal runaway begins around 200 degrees Celsius, which is very hot. An NMC battery, which is also lithium ion, may start at a lower temperature, 170 degrees Celsius. So it'll actually go into thermal runaway sooner. And then what happens next is actually equally important. Once thermal runaway is induced, lithium iron phosphate might go up to 400 degrees Celsius. Well, that's still very, very hot and concerning, but it's not as hot as an NMC battery going up to 675 degrees Celsius. Another consideration is that if gases are released, lithium iron phosphate releases less gas than NMC and other cobalt chemistries during a thermal runaway event. So that's good for a lithium iron phosphate battery to have less gas, because recall that those gases are flammable. On this graph, we're going to identify what happens to these various battery chemistries at various temperatures and the energy that's released. So as we move from on the horizontal axis from left to right, we are increasing temperature. You can see the green graph picks up first. It's the earliest temperature to start its thermal runaway or energy release event. The red line is the NMC battery that we've been talking about as a fire prone, it's used in electric vehicles often, some home batteries as well. And our LFP line is there. On the large graph, you can't really see it though. We actually have to zoom in 100 times to see the lithium iron phosphate curve. So again, it starts later, starts at a higher temperature, and it doesn't release as much energy before essentially collapsing back down to a non-energy released state.
Yeah, I think this is a great point, Chuck, if you don't mind me chiming in just a little bit here. So I want to point out what's happening to everybody. So basically what this graph is showing, this is a Sandia National Laboratory study, And what this graph is showing is we're taking cells and artificially heating them to high temperatures. And what that does is it heats up the electrolyte, which is inside these cells. All of these battery cells, whether we're talking about an 18650 or whether we're talking about, the new 4680s. So these numbers, first off, those numbers are just specifications for the diameter and the height of the battery cells themselves. So an 18650 is 18 millimeters wide by 65 millimeters tall. So that's what that 18665.0 means. But what's happening is we're artificially taking one of these cells and getting it hot to the point at which the organic electrolyte, which provides the mobility for the lithium inside these cells, gets hot enough that it vaporizes. All of these cells have a vent feature on the top of them. They have to be vented so that they wouldn't explode. So if you take a cell and you get it hot enough, you can vaporize the electrolyte. That electrolyte will then go through what we call an off-gassing cycle, where the electrolyte is basically boiling, turning into a vapor. And what is pointed out in this graph is the change in temperature for those battery cells as they go through this off-gassing event. And so what you can see, so a few slides earlier, Chuck was talking about the Note 7 and it going through a thermal runaway, and that was on a pouch cell, so it's a little bit different, but that's an LCO battery, a lithium cobalt oxide battery. And so what you can see is the lithium cobalt oxide batteries will go through an off-gassing event starting around 190 Celsius. You can drive any battery into one of these off-gassing events, but you have to get them hotter to get them to start. Once the off-gassing starts, that can result in a fire and energy and heat are released. So as these cells are going through the off-gassing event, they are rapidly changing their temperature, heating up and giving off energy. And so that's what's shown on the vertical axis is the heating rate of the cells, right, as a function of the temperature that you get the cells. And so you can see NMC batteries there. You can see the NCA batteries, you can see the lithium cobalt oxide batteries. So all of these batteries are going through the off-gassing. What Chuck pointed out is if you look at LFP, the lithium ferrophosphate battery chemistry, you have to get it above 200 degrees Celsius before you can even get the electrolyte to off-gas. And then when it does burn, it releases a huge amount less heat, right? So these other batteries are giving so much more heat off when they're going through an off-gassing event. And that's what makes LFP batteries so much safer for use in the home. There's really no risk of unmitigated thermal runaway. Can you go through an off-gassing event with LFP? Sure, if you get any battery, any lithium battery hot enough, it will do this. If you get a lead acid battery hot enough, the electrolyte inside that battery will boil, right? So this is why we use LFP battery chemistries for home batteries. Is there a case for NCA and NMC batteries? Yeah, they're a little bit higher energy density, a little bit lighter weight, and so for things like drones, for things where weight is a huge factor, other chemistries are preferable. But again, this graph really indicates by a national lab how much safer LFP batteries are, and this is why more and more batteries are switching to LFP, including Tesla. More than half of their mid-range cars are now being produced with LFP cells.
Thanks, Nathan. Very well said. So when we're dealing with one of these batteries that has a propensity, if you would, to have a higher energy release or a higher flammability risk, you may have to have additional equipment. And so this slide is outlining that for these cobalt-based batteries, they may need, like I said, ventilation, cooling, monitoring equipment. They may need to have, in addition to a way to measure that temperature, they may need the ability to circulate a coolant, have a fan to keep that coolant cold. All of these are moving parts. All of these are additional drains on the battery's energy. So when you have a battery that doesn't require these, not only due to its safer nature, it's going to be more efficient because it isn't running a pump and a fan and pumping fluids is a lot of energy. So our batteries are safer and don't require this extra equipment. We talked a little bit about the operating temperature. When we look at operating, we're talking about discharge. Our battery can discharge from -4 Fahrenheit to 140 degrees Fahrenheit. A comparable NMC lithium-ion battery may only be able to operate up to 120 degrees Fahrenheit. So that's discharging of the battery. Charging is a little bit of a different story. And some of these limitations are going to be specific to lithium-ion, and some of them may be more brand specific. But one thing we know about lithium-ion is that it doesn't like to accept a charge below freezing. When the cathode and anode are trying to exchange lithium ions through their graphite barrier, the ions become more resistant to that change or charge during cold temperatures. Further, if you are actually charging below freezing, you can have the icicles of lithium start to form, essentially little dendrites like we have in our brain. It's a word that means branches. So you can picture these little icicles forming like branches, and those are hard, and they will actually damage the cell, creating a condition where that cell may not be able to charge or discharge again in the future. At the most basic level, if you charge a lithium-ion battery below freezing, you can damage it.
Yes, so this is good, Chuck. If you don't mind me jumping in a little bit on the chemistry.
Absolutely.
So what's happening inside a lithium cell is we have migration of lithium ions from, in the charging cycle, from a cathode, which is typically a metal oxide. For us, it's a lithium iron phosphate. And so we are pushing lithium ions through an electrolyte, through a semi-permeable membrane, over to the anode side, the negative side of the battery. So we are pushing them through, and a couple of things happen at low temperatures. One, the movement of ions slows down due to the lack of temperature of the electrolyte. So you can picture a liquid as kind of a jiggling collection of electrons, which allows migration. And that migration is driven by an electric field, a difference in positive and negatives on either sides. And so what's happening here at very low temperatures is that these lithium ions get stuck outside of the graphite layer. And so there's a process called intercalation, and that intercalation process is the movement of the lithium ions into the graphite, where they meet with their electrons in the charging cycle. That significantly slows down at low temperatures. And what can end up happening is something that Chuck was mentioning, this formation of these dendrites. And these dendrites are basically, as he mentioned, you can think of them as icicles of lithium that are forming, that can damage the cell, as well as removing lithium ions from that battery's electrolyte. So charging for lithium batteries, and this is true for all battery chemistries, not just LFP, is that it has to be slowed down. And though this gives a charging range that prevents charging from happening below 32, you can charge, but at a very reduced rate. So if you have an advanced battery management system, such as the Amplify battery or the Simplify battery, you can actually charge these batteries at slow rates at low temperatures. And so our batteries with the advanced battery management system do allow charging. It's just drastically slowed down.
Fantastic. Thank you, Nathan. And to drive home another point, when we have this extended operating range on the high end, we reduce the need for coolant or HVAC or ventilation on the battery. So larger operating range gives you features that another battery would need auxiliary equipment to maintain. When we talk about charging and discharging battery, we have two opposite terms: the SOC, state of charge, and the depth of discharge. So this graph is just, or this image is just indicating that 100% SOC, or 100% charged, is 0% depth of discharge, or not discharged at all. When we talk about our batteries, we are always going to recommend an 80% depth of discharge, or rather you leave 20% left over in the battery. You can take 90% depth of discharge. You can take 100% depth of discharge out of our batteries. No matter what you do, we're going to warrant 10 years, 80% capacity at the end of those 10 years. Now, We anticipate, if you treat these batteries very, very kind, that you can get a much greater life cycle out of that, more than 10 years. So if you're doing an 80% depth of discharge, you may see many, many, many more years of capacity. Whereas if you are taking it down to 100% every day, we know that at the end of 10 years, you will still have 80% of the nameplate. So whatever it was day one, 80% will remain. And we'll go over this a little bit more in our installation section later in the presentation. We touched a little bit on BMS, which is a battery management system. The simplified BMS is going to be providing basic protections for the battery cells from overcurrent, under voltage, over voltage, and some cell balancing. So every one of our batteries has this BMS in it. We do have more advanced BMS, like Nathan was speaking about, like our Amplify and Simplify batteries. We'll go over those in great detail. Another thing that every one of our batteries has is a breaker, which is a great feature in my opinion. It's a wonderful feature for safety and transportation and installation and troubleshooting. If you are, using your torque wrench to attach battery cables to these terminals and you have that battery in the off position, you are in a safe place. If you are doing connections on a battery that's hot, you really got to make sure that you don't touch that torque wrench to both terminals. That could be a catastrophic and dangerous event. So by introducing a battery breaker on every unit, we provide the maximum level of safety for the user. When we talk about charging and discharging a battery, how do we measure that? Well, the way we measure it is known as the C rate. The C rate is the rate at which a battery is discharged relative to its capacity. So a 1C means that you can discharge the entire battery in 1 hour. Our battery is a C2 rate, which means it's going to take 2 hours to discharge the entire battery. Now, if you're familiar with lead acid chemistries, that's going to sound fast because you may be used to a C over 5, C over 10, which means, C over 5 means that lead acid battery can only be discharged over 5 hours. You can't get the energy out of it quicker. Now, a C rate is also going to apply to how quickly you can charge a battery. So if you have a C5 battery, it's going to take you 5 hours to really recharge that battery all the way. Whereas ours, in the right conditions, could be fully recharged in 2 hours. Well, what does this mean for your end user? It means that a relatively small battery bank can supply significant power. And we'll go over some of those details. Did you have a comment, Nathan?
Yeah, just I want to point out to people that most people are not really interested in discharging their batteries in an hour or 2 hours, right? They typically will size their batteries with a capacity to, be able to run their home for 12 hours or 15 hours. But everybody wants to charge up their batteries really quickly. They want to start up their generator if they have it, or run their grid, if they have it, or use a very large solar array if they have it, to be able to charge their batteries in 30 minutes, in an hour. You want to minimize the runtime that generator's on because you're paying for the fuel. And so typically batteries that can charge at a rate of 1C or 2C or 5C, these are typically batteries that have an active cooling system. They're less efficient, but they're more important for things like cars, right? Where you're parked at a supercharger, and typically it's a system that has active cooling that's running at high power, so you're a lot less efficient for your round trip efficiency. But that's how you can be able to charge at a really quick rate like that. I did want to point out just one logistical thing to people that are putting Q&As in the chat. There are a lot of good questions coming in, and some of them I'm leaving just for the end so that Chuck can address them at the end. There was a question about Tesla power walls. They use an NMC battery chemistry. But for the most part, I'm going to leave some of these good questions to the end just so we can have a discussion around them if you'd like. And some I will try to answer as you're speaking, Chuck. So thank you.
Thanks. So one of the great things about our battery is the scalability and expandability. Now, you may be used to a battery that offers you a 13.5 kilowatt hour chunk, and that is all you can build in. You can only do 13.5 kilowatt hours in a chunk at a time, and you're going to hit a ceiling at some point where you cannot add any more. You cannot scale further. Well, our 5 battery does not have that problem. You can expand our 5 battery basically infinitely. It's a simple parallel wiring configuration, so you just continue to parallel batteries, and you are not only increasing the energy by adding another battery, you're also increasing the power. So when we talk about that C2 rate, we have a 3.8 kilowatt hour battery that can be discharged at a C/2 rate. That 3.8 divided by 2 means you can get 1.9 kilowatts of power out of that battery. So not only am I building up in 3.8 kilowatt hour chunks, I'm also adding 1.9 kilowatts of power with each additional battery. So you're scalable on the energy and power side. And you can also expand with a traditional lead acid bank. It was not a good idea to add another L16 midlife. You would take that L16 and essentially kneecap it, bringing it down to the existing bank's level at any point. Now, that is to an extent true. We would recommend that if you're going to expand our bank, that you do it around the 2-year mark, not much later, depending on use. But that gives you the ability to say, okay, I've got a homeowner who had the perfect size bank. And then, what happens when people get solar? They leave the lights on a little bit more. So now they're using more energy. And now they need another battery. You don't have to give them another 13.5 kilowatt hours. You can give them another 3.8 and get them to where they need to be. So it's easy to build the initial scaled battery bank, and it's also an option to expand over time. Got a couple of pictures showing examples on the left. We have this big, beautiful bank. Each of these little black boxes is a battery. And then you've got these massive copper bus bars up top. This is an airport that has 80 of our batteries. It's roughly 300 kilowatt hours, which is large. It's a large bank, right? So that's a good example of how this end user needed us to scale for them. Likewise, on the right, we've got a customer with a sunny island and a combiner and 8 of our batteries. That might have been great for day one. Maybe lifestyles changed. Maybe they got an EV or something. They needed more energy. And so they added an additional 8 batteries to their bank, doubling the capacity. Now, in this instance, they didn't change out, you can't see it, but they didn't change out the sunny island. So they weren't necessarily maximizing their power. They're still using the same inverter, same combiner box, but we're giving them that flexibility to expand after day one. Not a lot of options on the market have that built in. So a big feature, if you're coming from the lead acid world, is maintenance. Now, with a lead acid bank, you may be familiar with watering your batteries or shooting the gravity to measure the electrolyte to see if the batteries needed more electrolyte or more water. It's a lot of opening of caps. You're messing with battery acid. So there's a lot of PPE requirements for, gloves and goggles and schmucks and stuff. So with our battery, there's no maintenance. You don't have to go back to the batteries and do a maintenance contract. You can install them, set their set points, and know they're going to work. Another feature is that they're not terrible to just sit around for a bit. They're going to discharge at about 1% a month. It's a relatively low self-discharge rate. We would caution you that is constant. So if you get a battery, or shipping our battery at a roughly 30% state of charge. So if you get a battery, you don't want to let it sit around for 3 years because that could self-discharge below 0% capacity. If you're going to let a battery sit around, we'd recommend charging it maybe once every 6 months, or at least making sure that you top it off before it goes into storage. And then it's going to lose that 1%, which gives you some time to get to installing it. Big takeaway there is that there isn't maintenance. And so this image is going to show you a very high maintenance bank on the left. We got a bunch of L16s. Each of those batteries has 3 caps to remove and check electrolyte and water on, ton of battery cable. You got a bunch of temperature sensors. It's a mess, right? On the right, we've got a Simplify bank. They've got our batteries mounted on some strut. They're going into a DC combiner. There's no maintenance to do here. You might refer to your electrical code and say, do I need to go back and check my torque settings periodically? But other than that, the batteries are going to be set and forget. So let's get a little bit into our products here. The Phi battery, 3.8 kilowatt hours. This is our workhorse. It's our most popular battery. A lot of people are installing these as, like in the last slide, as a flooded lead acid bank replacement. They're very simple to install. You just parallel them. They're scalable, like we've discussed. This variety comes in a 24 and a 48 volt. And like we spoke about earlier, it has an integrated battery management system. Now, the battery management system does not substitute for a poorly designed system, but a battery management system is going to help you if something out of the ordinary happens. If your generator runs out of gas and you're away and you're approaching a low state of charge, the battery management system can open up and prevent that battery from over discharge, too low of a voltage. And like I said, it's got a breaker. I love that breaker. More advanced, we've got the Amplify battery. Now this battery's got closed loop communications with an inverter. So what does that mean? Well, we're integrated with a couple of advanced inverters, Solarc and our new Simplify ESS. And what we're going to do is we're going to run communications from the battery to the inverter. And the battery is going to tell the inverter what it wants, what it needs, what it can do. Now, this is pretty cool. It enables an increased maximum discharge of up to 100 amps, because if the battery can communicate what's going on, it can release more potential. The inverter can draw more potential. It's also got the ability to do low and high temperature protection. Now, we alluded to this a little bit earlier, but if we are in freezing conditions, it's really bad to recharge the battery. Like Nathan said, if you can slow that charge rate down, it's not as bad. So what the Amplify battery can do is communicate to the inverter what its cell temperature, and it's important to differentiate between ambient temperature, which maybe is freezing, then the air temperature maybe within a battery cabinet, and then the temperature of the cells themselves, which, if air is freezing, the battery cabinet might be a little bit warmer. Inside the battery might even be a little bit warmer yet. So the battery accurately communicates its internal temperature, and through an algorithm, the inverter knows that it can discharge at charge at a reduced rate. This is a very cool feature. Like I said, Solarc and Simplify ESS have it. You plug it in with communications, it's going to auto-populate a whole bunch of set points for you, making for an easier commissioning. There won't be set points programmed for what I would call customer expectation set points. We're talking about that depth of discharge. If you want 80% depth of discharge, you're still going to want to program that. What about when your generator turns on or so forth? There's still going to be some customer expectation set points that you'll need to program, but it helps with commissioning. And it also enables some flexibility in design, where if we'll talk about sizing here in a slide or two, but if we're using a smaller than recommended bank, the Amplify can actually tell the inverter how much power is available from the bank, so the inverter doesn't draw too much.
So Chuck, this is an excellent opportunity to kind of plug one of our other trainings. So there are still a lot of people out there that like to use other battery chemistries, acid-based battery chemistries that can operate in lower temperatures. Despite the fact that, and as you're going to get into with the levelized cost of energy later, despite the fact that lithium, if you look at the round trip efficiency, compare the cost, etc., you're getting a lot more kilowatt hours stored and used for a lithium battery. And one of the reasons for this is people don't know how to deal with the low temperature issues surrounding charging for lithium batteries. But I want to point out we have whole training around extreme environments, but also insulating these batteries, keeping these batteries inside an insulated case. All we have to do is prevent the heat from the batteries of leaking out. So all batteries produce some heat due to internal resistance as they charge and discharge. So we have a number of solutions that can help you in low temperature environments if you would like to use these batteries in low temperature. We have some integrated smart heating pads that can interface with our batteries, monitor temperature, and the batteries basically sit on these heating pads and keep the batteries at an appropriate temperature for charging, even when environmental conditions are cold. People have also just kept the batteries inside insulated cabinets, and there's obviously a big difference between the battery temperature and the environmental temperature. So I want to point that out and highlight that we'll have one of those trainings coming up. I think the next one is in January. So if you're interested in using these batteries in low temperature environments, please look for our extreme environments training that will be advertised by email in the next few weeks. Thanks.
Very cool. Next up, we've got our 5 batteries in a 1.4 kilowatt hour form factor. Now, these guys are a little bit smaller. They're 12 volt or 24 volt. And they have that black ABS case, which you may be familiar with from our products from a couple years back. It's more corrosion resistance, lighter weight, great for mobile applications. This would be something where you might be able to drop these batteries in an RV or in a boat to replace an existing lead acid battery. They are compatible with standard charge controllers and inverters, just like the rest of our simple product line. And they still have that BMS and breaker. So this is a really great product that is just like all of our other products, but smaller. Smaller yet, we've got our Expeditionary line. We've got on the left, we've got the fold-outable solar panel with the Big Jenny emergency kit. You got 1,000 watts of capability and recharging on the go there. The Little Jenny, smaller battery, all of these 3 have a built-in inverter charger. So you're able to, run some loads and recharge this portable battery on the go. Bigger yet, the Big Jenny kind of looks like a suitcase on wheels, capable of 1,200 watts. So these are a great product in case of emergency or in case of fun. You could take them camping, take them to a concert or a football game, do some tailgating, bring your power with you. Also portable is our Express. Now this is a battery cabinet on wheels with a built-in inverter charger. In this enclosure, we have the MagnaSign inverter charger and a charge controller. So we can use a DC input like a solar panel to recharge it. It's also got an AC inlet. So you can literally just plug this into a wall socket to recharge and wait for an outage. It'd be great in an apartment or something where you have minimal loads, but you still might have the problems of losing power. It can give you some autonomy on the go. Bigger yet, we have our access cabinet. Now this is going to be a built-in inverter and up to 6 batteries. You can see here, we're running some Amplify batteries because they've got the built-in communications to the solar. We're also going to have this product with Schneider. Those are already out, and we are working on releasing it with our Simplify ESS. So this is a great energy solution for dropping in AC or DC coupled. It's NEMA 3R ready, so you can put it outside. You got to pour a little pad so you can fix it to the ground maybe, but you can, like Nathan said, you can order from our factory to have the integrated heating solution where the battery will have a thermistor in it. That thermistor is going to control an external heating pad that you'll put underneath the batteries. So if you're in an outdoor installation where you might have cold weather, you can keep your batteries warm, which again allows them to accept a charge. Bigger yet, we got our Boss cabinet. So the Boss 6 is a shorter variety. It's kind of like the bottom of that access cabinet. Boss 12 is the taller cabinet with up to 12 batteries in it. So these are great ways to take maybe that access and expand your energy capabilities, but it could also be DC coupled to a standard inverter charger, a hybrid inverter. So this could be the battery pack that you propose to your customers. It's a 9540 certified solution. Again, that's based on the 9540A fire testing that we've put it through, but it's a really great way to offer energy as an expansion. Now, these outdoor cabinets also have a fan in them. So we've talked a lot about cold, but hot is also a thing. So having some fans to circulate air is crucial to keep those battery temperatures from being too high. We also have high voltage, an entire team dedicated to this. They can do an indoor rack, they can do an outdoor container, small or large. So if this is something that your company is interested in, or if you know a customer who needs this kind of larger energy storage solution, contact us. We can put you together with that team. They'll build you a customized quote to give the solution that you need. Comes with all the features that we've been talking about from our batteries, great chemistry, the lack of a need for some of these auxiliary systems. And it's just a really great solution as more and more large entities are looking at energy storage as a way to avoid some of the pitfalls being connected to the grid. We've talked a lot about it, and I'm really excited to present about the Simplify ESS. So this is a true vertically integrated energy storage system. The Briggs & Stratton has enabled us to leverage their manufacturing experience to offer this integrated inverter and battery. We've also got a way to monitor the system. So you as the installer could be monitoring your fleet through Energy Track. You could be giving the homeowner access to their energy solution in the palm of their hand. We've got a 6 kilowatt inverter. Now that is stackable, up to 9 of them, for 54 kilowatts of power, which is a fair amount of power. Like any good backup solution, it has a seamless transition. So your customer won't even notice the power just going out and being backed up by the system. And it has a screen. I'm old school and I love this screen. The screen gives you the opportunity to go out and look at the inverter, see what it's doing. You know, I got sad when inverter manufacturers on the solar side started to remove screens from their products. I feel like that was a step not in the right direction. You know, offering a screen also offers you that additional resiliency. And you know, if the power's out, maybe a tree came down, maybe it also took out the internet. And so, you know, the mobile-based apps that some of these other systems are relying on might not be able to ping to the inverter from the cloud. And so your user doesn't have any idea what's going on. Maybe they have an LED light, but they're not going to get, you know, detailed information about their state of charge or what their loads are doing. So we're really enabling them to have control of their own power and energy. It is IP65 rated, which means you can mount it outdoors. And the great thing about an integrated solution, a vertical solution, is that it's the same warranty as the batteries. It's the same tech support call. It's all one line. The battery that we are releasing with this is the 4.9 kilowatt hour. Now, this is the same chemistry we've been discussing, still has a breaker, still has that closed loop communication that makes the Amplify battery so special, but it's a larger form factor. It's 4.9 kilowatt hours. Now, I've heard feedback about some AHJs having a ceiling of 20 kilowatt hours before the installation becomes more problematic. This is a great product to drop 4 of these batteries in, stay under that 20 kilowatt hour ceiling, and simplify your permitting and installation process. Again, IP65 rated for outdoor installation. There's a hood that you put on top of the terminals there so that it's watertight. And again, the 10-year warranty that comes with the Simplify brand. Energy Track is the way you're going to monitor your system. It's the way you're going to get over-the-air updates. It's the way you can make some configuration changes and commissioning to the system. So this is going to be an external box that allows that communications and then the communication on the app itself. Our commissioning process is fast. When you've sat through an alternative energy storage systems commissioning, you know how painful that can be. It can be a couple hours. It could be a couple of days. So ours is going to be quick and, of course, simple. Nathan alluded to it earlier. Levelized cost of energy is a concept where when we're talking about price, there can be price objections about an upfront price being too high. But an upfront price isn't the only price a customer is going to have to pay. When we look at the levelized cost of energy, which is the cost of that energy over the life of the system, our product is actually often much cheaper because while there may be a higher upfront price, there isn't that maintenance, there isn't that auxiliary equipment, there isn't the need to replace the battery bank at 5 years because it's lead acid, and that's just how long they last. You may be familiar with levelized cost of energy from some other industries like solar. When we talk about panel degradation, levelized cost of energy is a selling point where you say, hey, that cheaper panel is going to degrade a lot faster. And so at year 25, it will make you less kilowatt hours than this similarly sized panel, or more expensive, but with lower degradation. Same concept here. You know, when we talk about 80% of our nameplate capacity being available at year 10 under warranty, other manufacturers just are not offering that. They're saying 70, maybe lower percent of what their nameplate is, which means that that percentage lower is kilowatt hours that you don't have at the end of the warranty period. Now you can calculate all of this. We have a calculator on our website that'll help you do it. But when you're conveying value to the customer, what do they want? They want to not worry about it. And so replacing equipment, auxiliary equipment, moving parts, all of these things may drive your levelized cost of energy up over time, whereas our product doesn't have all that. And thus you can demonstrate, while there may be a price objection for a higher price up front, the value to the customer over time is greater. We'll talk a little bit about sizing and then installation. We alluded to it earlier. If you take our battery down to 80% depth of discharge, we anticipate 10,000 cycles out of that battery. What does that mean? Well, if I'm cycling that battery once a day, that's north of 20, 25 years. Now, you can cycle to 90%. We anticipate you'll get something like 5,000 cycles out of the battery, and 100%, if you're really going through that battery all the way every day, we're still going to give you 80% of nameplate at year 10. But that may be it. After year 10, there may be degradation that brings it below 80%. But if you're cycling it lightly, we have every expectation that the battery should give you way more than 10 years. We're only going to warranty to 10 years because it's an industry standard, and it's, we don't want to warranty a battery for 25 plus years, but we anticipate that energy will be there if you take care of your battery. Well, what installations might be applicable for such use? Well, if you're using battery backup, maybe a couple dozen outages a year, a couple dozen cycles via an outage, 100% depth of discharge may be appropriate. We'd like to say 90%, gives you that little 10% left over in there, just to make sure that the battery has enough to kick back on after the outage. If you're off grid and you're cycling that battery every day, 80% is appropriate. And it's going to benefit you too, because you'll have additional capacity after the warranty period. If you're cycling more than 80% in an off-grid situation, you may be looking at replacing the bank after the warranty period. Similarly, if you're doing that peak shaving that we showed you up front, where you're only really cycling the top demand off of your usage, you might be able to have a deeper depth of discharge because you're not using the battery as frequently, or you may not even be taking it down to that depth of discharge. Your demand cycling might be just taking the top 10 or 15% off the battery. And similarly, for a zero energy home, or truly like a time of use arbitrage kind of setup where you are cycling that battery all the way every day, again, we'd recommend 80%. It gives you the peace of mind that battery will give you that 10% or 10-year warranty, but that it'll also continue after that.
So Chuck, if you don't mind going back to that previous slide just for a second, and I know that we're running out of time here, so or out of time, but this was a couple of people asked about this in the Q&A. So it's important to point out here that there's a drastic difference in the number of cycles, the number of kilowatt hours you can put into and take out of the battery when you're only discharging down to 80%. Now, keep in mind, these numbers are based on only cycles of to 80% depth of discharge, right? We know that all homeowners are probably going to have a mixture of different cycles, but this goes to show you what we expect out of a battery. So 10,000 cycles, that's, the sales number that everybody says is 27 years, right? But we know in reality, sometimes the battery is going to be maybe discharged 100%. You do that 100 times, not a big deal for a battery. do that 3,500 times, that might be the end of life of the battery, right? And so it's important to keep in mind that the batteries are most sensitive at high depths of discharge and then sitting at high voltages and high temperatures. So if you keep those two things in mind, you are going to be experiencing between 5,000 to 10,000 cycles on your battery and be getting between 10 to 25 years. So don't abuse the battery, and the battery will last you a long time. Anyway, I took up time we didn't really have, so I want to let you be able to wrap up, Chuck.
Yep, here we go. So quick sizing example, this is an Outback rating. It's an 8,000 watt inverter. We have a C/2 rating. So if I've got 3.8 kilowatt hour batteries, C/2 means they can do 1.9 kilowatt. If I do the math real quick, I'm going to discover that this Outback Radian needs at least 5 batteries to provide the power that that inverter is capable of. If you undersized it for less than 5 batteries, that could be a problem where the inverter pulls more than the batteries are capable of. The system is oversized. They've got about 14 batteries here, so they'll be able to provide whatever that inverter needs. We have integration guides and sizing help. Just contact training or technical support. We can walk you through it. We also have a ton of tools on our website about sizing, about the lithium-ion battery size that you should do, or the lead acid replacement size that you should do. Real quick on installation, read the manual. We also have spec sheets and integration guides on our site. And integration guides are going to walk you through a specific inverter or charge controller's set points, and then our recommendations on those set points. So it's really intuitive to use. It's going to give you those set points as they come out of the equipment you're programming on. So, if it's called low voltage cutout or low battery cutout, we're going to be treating those set points the same way the inverter or charge controller manufacturer treats them. When we talk about mounting, big takeaway here is that we don't want to mount them upside down or stack them on top of each other. You can put them side by side. You can put them in wall racks. We have the access cabinets and the boss cabinets as well. An example of parallel wiring. So we're always going to parallel our batteries, never series them. So what do we got here? We've got a bunch of red positive connectors landing on a common positive bus and a bunch of black negative connectors landing on a negative bus. So this is an example of parallel wiring. The other thing you'll see is that this black wire takes some roundabout ways to get there. That's because all these battery cables are the same length. That's going to keep resistance to the batteries equal. If you have different battery cable lengths, the batteries will see different resistance and will discharge in uneven ways. So it's important to keep in mind, always parallel, and for our 5 batteries, always have these similar battery cable lengths. One of the ways you parallel those is through a DC combiner. This is the Midnight DC combiner. It's a 1,000 amp rated, so you can put a ton of batteries in here. And when you are installing, we're going to recommend that you read the manual and install according to our torque settings. Now, we're going to recommend 160 inch-pounds, which may not be as tight as you feel like it should be. But what we really want to stress here is do not hit our batteries with an impact driver. Solar installers love their impact drivers, but that's a good way to over torque the battery and snap the terminals off. We see it often and has to result in an RMA, which is an additional cost for you. So take the time to grab that torque wrench. Ideally, it's an insulated torque wrench, but again, our battery has a breaker, so you can make sure the terminals are not hot while you're doing your work. A couple examples of a single line here. We've got a DC coupled system with a Solarc. So we've got DC on the roof with some rapid shutdown and 2 access cabinets or boss cabinets with one of those Midnight combiners and a backed up load center. We can also do AC coupling. Here's an example with Enphase microinverters and a Schneider setup. Again, double boss cabinet. This is going to be a large energy storage for that customer. And we can also offer our new ESS with a number of configurations. Here we've got DC coupled on the roof. So we've got our AP Smart rapid shutdowns because the inverter comes with an integrated AP Smart transmitter. We got our rapid shutdown initiator, our Simplify ESS batteries and inverter. Oh, what's this down here? This is a Briggs & Stratton generator. Well, this is a great way to, if your homeowner has a standby generator, What happens when an outage comes along? Well, that generator runs the entire time that the power is out, right? So there's a lot of runtime, a lot of noise. A great concept is to pair a generator with energy storage. That enables you to run the generator to refill the bank, and then let the generator rest, have some peace and quiet. When that inverter sees that the batteries are hitting their set points, it calls the generator back to action, and all the while you're continuing to feed your backed up load center. Real quick, I want to go over our Elite Installer Qualification, or IQ program. What is our IQ program? Well, we're looking for installers who are working with our products and know what they're doing. We want to include you in our newsletter, so there's some free marketing there for you. We'll also get you some swag. We also put you on our map, where a homeowner or someone who's watched one of our webinars has decided that the Simplify product is what they want. Now they need to find an installer in their area, and they can do that from our map that shows all of our IQ installers, we'll be giving them your contact information so they can reach out and get an install quote from you. We also have a rebate program specifically for IQ installers, where $25 per battery is available to you when you do a warranty registration. In December, we're doubling that to a $50 per battery rebate when you do a warranty registration. So if you buy those batteries in December and you can show a proof of purchase with a December date, you don't have to install them in December, but you do that warranty registration when you get around to installing them next year, and we'll notice that December purchase date, and we'll give you that $50 rebate per battery. We also have a photo contest. We love pictures of our product. We think our product looks great, and we love seeing our installers, our homeowners pets in pictures with our installs. And to that end, we will give a monthly winner of our photo contest $250, and it's a rolling entry. So if you entered in September and didn't win, don't worry, we still have your photo, and we can look at it again in December, a future month, and get you that bonus for sharing your photos with us. If you want to sign up for the Elite IQ program, here's a link. We'll be sending out the slide deck so you can click on it. You can also navigate to our website and look up IQ, fill out the application. We'll contact you, have a brief conversation, and get you on the map. In addition to these webinar trainings, we are also able to leverage Briggs & Stratton's Power Academy for on-demand training. There's a ton of generator trainings on there. We are starting to add more energy storage trainings, and eventually we will have NABCEP certified CE courses on demand on Power Academy. So if you want to sign up, you can go to the link here or text LEARN to 33988. And thank you. If you want NABCEP credits for attending this webinar, that is the email to email us, training@simplifypower.com. Be sure, like I said at the top, to include your name, how you want it to appear on the CE credits. If you're Bob, but NABCEP knows you as Robert, be sure to point that out to us so that we get you the certificate that says Robert. Now, we appreciate you as being here as we went a little bit over time. We'll go ahead and go to the Q&A section. And feel free to keep adding any questions. First one I see on here, what is happening with the SGIP program that has been exhausted? Ken, I believe you're referring to the equity resiliency budget, which for many utilities has been exhausted several times over. I believe the good news is that despite all the bad news about NEM3, part of the deal is that there should be new funds allocated to SGIP. I don't know the exact amount or timing, but I believe that was part of the bargaining was, hey, if we're gonna reduce export rates and encourage people to get batteries, let's keep the rebate program alive for them so that they can take advantage of it. So I would keep an eye on the SGIP site, see if those budgets get replenished, and then submit your application right away, because we know from experience that those rebates went really fast. Ken also asks about commercial for medium to large projects. And yes, we absolutely have an entire division of high voltage team that is able to work with you to design the system according to your specifications.
Thanks, Chuck. I'm going to connect Ken. I kept this one on here because he was asking about NEM3 as
Yep.
well as 80% depth of discharge on killing batteries, etc.
Yep. And so I do agree that NEM3 is unfortunate. Draconian is a word to describe it as well. Where I think energy storage is going to be so crucial in that NEM3 world is, again, when we discount export rates or eliminate export rates, your rooftop solar is devalued. So fortunately, NEM1 and NEM2 customers look like they will be grandfathered, but anybody who's coming to solar in the future, they don't get in on that NEM2 tariff, they're going to be, like you point out, reducing their exports by 80% or more. So it won't make sense to export. It's going to make more sense to store and self-consume power.
And it's a good question, how long it's going to reduce the, how much it would reduce the ROI, right? So what customers really want to know is, okay, how long does it take for my savings to pay off the system I've installed? And when do I actually start kind of making money from the decision that I made on my investment?
Mm-hmm.
And I think you're better able to speak to the sales side of things, Chuck, on that. I know NEM is different, but
my old sales team would tell you that this is their least favorite answer. It depends. So there's going to be several factors that affect ROI. Where I see the highest return on investment in the future is going to be coming from relatively small grid-tied solar systems with battery backup. The reason being that you ideally are self-consuming your power on a day-to-day basis so that you're not exporting that power again, right? So, the days of full offset where you're attacking your annual kilowatt hour values maybe aren't as good of an investment. But these systems with, essentially, if you're able to self-store and self-consume your battery within the same 24-hour period, you're going to have a decent return on investment. You're going to want to run it based on that customer's usage, not only how much power they use, but when. And then, essentially, to turn the utility's term against them, what is the avoided cost of not buying from the utility during those peak hours? So, using some advanced modeling software, I did a bunch of it, and the NEM3 projections that were out at the time looked like we could keep a smaller system under a 10-year return on investment, which is still a great investment. But, a standalone solar system is not going to reach that kind of return. The tariff they're writing is intentionally trying to extend the return to something like 9+ years, which, again, draconian might be an appropriate word for that. And if that didn't answer your question, Ken, hop back in and type in another one for us, please. What is the plan for end of life? Recycle, replace, refurbish? And when does that occur? So yes and yes for recycle and replace. So depending on how you've used your batteries and when that end of life occurs, we do want you to recycle them. Like we said earlier, they are not landfill safe. And then you consider replacing them. Hopefully your experience has been that with a Simplify battery, you got that 10-year warranty period plus, and that it demonstrated an excellent value, and you want to replace it, right?
So Chuck, there's just one thing I want to add here. Lithium recycling is somewhat in its infancy, but it is happening. And Redwood Materials is a good example of a former Tesla executive that started a battery recycling plant. So these batteries are 100% recyclable. One of the nice things is that the LFP batteries don't contain cobalt in them, and so they don't have that toxic metal. So it's not considered as hazardous of a material to work with as NMC batteries are, and other cobalt-based chemistries are. But again, recycling is happening, and I imagine that industry will be growing and growing, especially as electric vehicles grow.
Absolutely. To the third part of that question, refurbish, not so much. Generally, when these cells have used up their usable life, recycling is the path. And when that occurs, again, that's going to depend specifically on how you treat your battery. Like we said, if 80% depth of discharge, we anticipate well over the 10-year warranted, potentially over 20 years of life. What about overcharge protection? I believe, Joe, you're asking about the BMS And the BMS is going to have some overcharge protection. It does not substitute a well-designed system. So when we talked about how quickly that inverter could draw from those batteries, we also want to look at our charge sources and make sure that we aren't setting the system up for failure in a design where it has the ability to put in more charge current than the battery bank is able to take. So each of our integration guides starts off with a couple pages about how you do that math. Feel free to reach out to the tech support or training team if you need assistance with that. We can also put you in touch with a sales application engineer to help pre-design a system that, you know, the BMS is not a backstop that we want you using regularly. We want you designing the system per spec, and then the BMS is there essentially for anomalies. Disconnect may destroy operating inverters that are connected.
I think what he's talking about here is the BMS protection in the 5 batteries. Again, the settings, so what protects from overprotection is the voltage settings that end your bulk charging cycles. For instance, you can float these batteries, and if you have a renewable power source, but basically you want to make sure it's in our manuals, you want to make sure that you get those settings correct, so that the end of this bulk cycle, which goes into absorb cycle, ends at 56 volts for our batteries. And if you do float them, we recommend you float them at 54 volts. As long as you have those programmed properly into charging equipment, you should have no issues with overcharging. If that voltage goes above 62 volts, the BMS will automatically disconnect the battery to prevent damage. But again, you shouldn't rely on the BMS to do that. You should program things properly. Hence, as Chuck was saying, read the manuals. But then if you have any questions when you're commissioning your system, please feel free to reach out to our tech support. We don't put you on hold. We take your calls as they come in, and we will help you through that process if you have questions.
Absolutely. How many cycles in the life of a battery? Well, within the 10-year warranty period, we are not limiting the life or the number of cycles. So where we would limit is the depth of discharge. We don't want you discharging more than 100%. So now if you had a system that, because of the configuration, you're able to charge and discharge those batteries multiple times of the day, it would be a really good instance to look at that 80% depth of discharge to make sure that you don't exceed the anticipated cycle life. But we are not, you know, as a lot of manufacturers are, we're not attaching a number of cycles to the warranty period.
Yep, it's 10 years even at 100% depth of discharge. The number of cycles you'll get out of the battery will depend on how you cycle the battery. So we tried to address that with an earlier slide. But you know, even an abused battery, even a battery that's used pretty hard, we're still expecting more than 10 years of lifetime. And that's why we can give that 10-year warranty without limiting, as Chuck said, the number of cycles. Cycle as many times as you can in 10 years as makes sense for you. And you still have that warranty as long as your system is sized appropriately.
And then what is the warranty or guarantee on these batteries? It's 10 years. 10 years is our warranty, period. Is the 10-year unlimited cycle warranty in terms of operation, engineering, or business? Meaning if I discharge my battery over 80% every day, would the battery need to be replaced, although covered by warranty by year 10? If I understand the question, no, you should not need to replace your battery if your set points are correct. Even if you're going over 80% every day, we're warranting for 10 years. If that doesn't address the question, please hop back in the Q&A and clarify. But again, it is a 10-year, regardless of cycle number. You just got to stay within those set points for, you know, don't over discharge the battery. That would probably be the biggest takeaway there. One more time, how the generator will power the battery when the solar is inadequate. Great question, Michael. So what we're talking about when we pair energy storage and a generator is the ability for that hybrid inverter to call the generator into action at a low voltage set point. So you know, if we're talking about not discharging the battery below 100%, maybe we call the generator into action at 80% depth of discharge. So if my solar is inadequate because it's nighttime or winter time or covered in snow, and my battery bank is approaching that set point, the hybrid inverter may have the ability, and you'd want to look at your inverter. Our new ESS does have the ability to 2-wire start a generator. So essentially it says, all right, generator kick on, generator kicks on, and then the generator power goes through the generator port. The inverter charger or hybrid inverter charges the battery bank up to another set point, generally, 90% or so. So the battery bank is almost topped off. And then rinse and repeat. If that battery discharges to that set point again, it calls the generator back up. What it prevents is that generator running constantly. The generator is just called into action when the batteries need to be recharged. Hopefully that answers your question.
And I think that's it. Glenn, I think that maybe you have to click on the Q&A to be able to see the questions, and there are now 30 answered questions, so people can review those. In terms of receiving the slides, Chuck is going to email the slides out to people in PDF format after this presentation. You will also be receiving an email from our marketing team with a link to this recording, which will be posted to YouTube. So we'd like to thank all of you for attending, and we thank you for the questions. I think it's the most fun part of the trainings for Chuck and I. And if you have more questions, feel free to email us at training@simplifypower.com. Thank you, everyone.
Thanks, everybody.